This is a presentation of the ROS on Docker workshop by Paul Bouchier, and I will post the URL in the chat. And the purpose of this workshop is to get participants familiar with how to run both ROS1 and ROS2 inside of the prepared Docker containers, and to operate the scripts that I've prepared for using with those containers. So, and I'm here with Kareem. We're going to work through the exercises, or through the tutorial material, and then there are some hands-on exercises which we may or may not do live. We'll see how we feel about them, but we will walk through the exercises to understand what's being asked here. I'm going to share out my screen, and you should be seeing the ROS2 Docker workshop and a terminal window.
Yep.
Okay, so what we're going to cover is Docker concepts, and the difference between images and containers and layers and what all those things mean, how we use them in the robot environment, how to install Docker and get the scripts and repo that I've prepared installed and working, and how to use them. I've got a Docker command line interface cheat sheet. And is this big enough for you to read, Kareem?
A little bit bigger would be helpful.
Okay. How about that?
I don't think you increase the font size. You just increase the white space.
It's showing bigger.
Oh, it's definitely bigger now. Yeah.
Okay, good. Yeah, because it only records at 720p, so it's actually helpful to have it big. So these are the sort of the everyday use commands. You mainly use Docker from the command line, and so you can list images and containers, and we'll go over the difference between them. System prune is good for cleaning up stopped containers and dangling file segments, which you tend to accumulate after a while of working in a Docker container. Oh, it looks like someone else wants to join the meeting. Brian Taylor. Good evening, Brian. Okay, your microphone is muted, Brian. Can't hear you.
He might not be set up with a mic at the moment or something.
Yeah.
Just where do we do you want to just record this straight through, or do you want questions in between, or like I don't want to. I know you don't want to be thrown off into rabbit holes and things like that.
Yeah. So actually, questions are great and just because they help clarify anything that I didn't explain clearly, and so yeah, bring them up. If it seems like a rabbit hole, I'll defer.
Okay. Cool.
Brian, looks like you're off mute. Can you hear us and talk to us now?
I can try. Try. I wasn't talking, but it's nice to see you all again.
Well, welcome. So we were just getting going on the ROS Docker workshop with Kareem, and I assume that's what you're here for.
Yes, sir.
Excellent. So I'm just going through the command line, the cheat sheet for the things you would typically do with Docker from the command line, and saying that the image and container, I'll explain the relationship between them. System prune cleans up containers and dangling file systems, which you'll end up with a few of after a while. Docker image RM and then an image name will remove a specific image. Docker build -t image name dot builds an image from a Docker file in the current directory. And then Docker run and a script name will run a script. Docker exec launches another process. You typically use that to launch a shell in a running container. And then Control D is how you exit a Docker shell. Okay. We use Terminator quite a bit, or I suggest using Terminator quite a bit, because ROS tends to want lots of terminal windows, and Terminator lets you split a single terminal into a whole bunch of sub windows, and we'll take a look at that. But Control Shift C, same as in a regular terminal, copies selected text to the clipboard. Control Shift V pasted it. Control Shift T gives you a new tab, and Control Shift N gives you a new terminal window. So container concepts around Docker. So it's a virtual environment, except without the isolated kernel that you have in a virtual machine. So the kernel is shared between multiple containers, but the kernel provides isolation between containers and apps running natively on the OS. So, for example, when you run PS in a container, you'll only see the processes that are running inside the container. Similarly with the files in the file system, you get your own, what appears to be your own home, but it's isolated from everything else on the host machine's file system. So it acts like a virtual machine, but it isn't. The kernel is actually shared. So it's virtual in the sense that apps run in an environment that looks like they have their own machine running its own OS, but they don't. And they're really kind of a halfway house between apps running in a VM and apps running on the native OS, because the container contains all the libraries and executables that are above the kernel interface. So it's independent of the environment of the host running the container. So typically you would put lots of your own apps. For example, the ROS software system would be in the container, and that's all application level layer software. It makes system calls down to the OS, and the OS services those system calls. And the kind of neat thing about Linux is the OS interface is very stable. So apps tend to just work on about any host OS. But whereas the libraries and applications are specific to whatever container you're running. Did that make any sense? Any questions that arise out of that?
This was one of the things that I was confused about early on, was the fact that, whenever you look it up, they talk about a shared kernel, and like which kernel is it? What I'm gathering is it's the one on the bare metal machine on which you install Docker, and whatever that system is, you're going to be using that kernel. And yet I was aware that, like, say, Ubuntu 2004 is different, has a different kernel than 2404. And but yeah, it seems that there's enough stability in the kernel that you can run all the user space stuff associated with 2404 on top of the kernel that comes with 2004.
But yeah, that's exactly right. Specifically, it's the kernel API that they hold so stable. They may well change all kinds of implementation details, but you don't see it from the application, from the kernel interface layer. And that's where Docker containers interface to the OS.
And presumably, like in this context for ROS, when there seems to be such a tight coupling between a specific ROS version or ROS release and the Ubuntu version it's based on, that's all happening in user space dependencies and libraries and things like that. So it doesn't really matter.
Exactly.
Okay.
Exactly.
It took me a while to wrap my head around that one.
Yeah. You got it, Kareem. And so, as you say, the consequence is that you can run Ubuntu Humble or the latest Ubuntu Jammy, which is tied to Ubuntu 2404, I think, and then not and have all the right ROS libraries built into the container, and the OS interface stays the same. So you could run it on probably 18.04, an 18.04 host, or conversely, you could run ROS in. I've spaced its name. Noemic, ROS Noemic.
Noetic, yeah.
Which is tied to Ubuntu 20.04. You can run that on Ubuntu 22.04 or 24.04. So yeah, it's a neat technology. Okay, so moving along to images and containers. So think of them like an image is like an executable file on your PC, on your file system, and a container gets instantiated from an image, much as a process gets instantiated when you run an executable. So the process is different than the image, the executable file on disk, but it's instantiated from the file. And similarly to that, a container gets instantiated from an image, and the container is what runs the virtual environment. So that's the thing that is executed by the Docker daemon and whatever other software is sort of native to Docker. But there is a difference. So the analogy only goes so far. So different than the process and executable analogy, a container exists on disk and could have changes made to its files, and those changes would persist for the life of the container. We don't do that. I'll tell you how to do it, but it's not a best practice for Docker. But think of the Docker as the runnable form of the image, which provides the virtual environment that can run the apps and the libraries and all our software. So in our way of using Docker, we won't let containers persist, even though they could, and there's a flag we'll go through that optionally lets you do that for testing. But we'll delete them by default when they shut down. So we use them as a short-term resource for running apps inside of. And we choose to persist any changes that we want in the image rather than in the container. So what I mean by that is we rebuild the image when we want to make changes to the container. So a very common use case is that you want to add some new app or some new library that's needed by some software that you're running. P2OS needs some ROS package. So we will rebuild the image and put it in the image so that when we launch the container, it will be there because it's in the base image. And the benefit of that is it keeps our configuration defined by the Docker file. So the Docker file is what's used. It defines how the image gets built, and that's where we put the statements that cause apps and libraries and packages to get installed, and so it keeps the Docker file ends up being a record of what this image should be like. Does that make sense?
So that makes sense to me. This is one of those areas where I feel conflicted, especially when I think about the fact that I'm so new to ROS 2 and and just wanting to play around a lot, and the idea of sort of stopping everything to go rebuild the image while I'm doing experimentation seems a bit laborious. I get the reason for the methodology, and it seems much more in tune with things like managing production environments and things like that, where you're really concerned about repeatability and sharing it with other people. But if I'm in an isolated place just doing my own thing, I wonder what's the harm of persisting the actual the container
So let me
across a few
clarify.
sessions. Yeah.
Let me clarify that a bit. You can install new packages in the container, and that's the normal way that you would test out some change to it. So you try and colcon build your package, and then you find it needs another package, so you sudo apt install the second package, and then you find the next problem, so you sudo that apt install that, all inside the container. So you modify the container, but once you've got it to a stable point, then you would put the proper commands into the Docker file so that the image will be updated next time you build it. Then you can delete the then when you exit the container, it will lose the things that you installed, but building the image is actually quite quick. It just takes a minute or two, and then next time you launch it, you've got it there. But I will walk you through on how to break that rule if you so choose. But then you obviously bear the responsibility for the consequences.
Yeah, clean up. Yeah.
Yeah. And Brian, feel free to interrupt with any questions that you may have as we go along. I think questions help because they can clarify things like the question that we just had that aren't clear.
Completely understand, and I will, no problem. The
Great.
concept makes sense to me of like when you're you don't want to save the random changes you make because you're experimenting permanently. You want to do it with intention on the master copy so you don't get any oopsies. I mean, the concept is super clear. Thanks.
Yeah, and just to contrast that with what you do on a PC, sometimes it's not clear what package you need or what version where you should pull the right package from on GitHub, for example. So sometimes on a PC you'll download an image and it still won't build, and it'll be because you should have pulled a version from someone else's repo. Stuff like that. Well, on a PC, you tend not to clean that up, and you tend to end up with extraneous stuff laying around, which may cause trouble later. So that's, I guess, another hygiene benefit of this approach. But there is a way to persist a container and relaunch it, and that can be convenient for testing changes. And particularly in the kind of scenario that we're talking about. So I provide a flag when you launch a container that says don't delete it when you exit. The other risk that you take is Docker prune system gets rid of all of the junk that it can find, including stopped containers. So if you've made a bunch of changes to some container and are expecting it to hang around, and then you have all these file segments, which can grow over time, and you may lose it. So there you go. So images now are built up in layers. So in the Docker file, we instruct the Docker image builder to install apps and make other changes. For example, create subdirectories, put in symlinks. You can do anything that you can from just about from a bash shell. And to make these changes that will end up in the container when you launch it. So I own the content of the containers that we'll use, but I provide a template so that you can build on top of my containers and create your personally enhanced container. And I have a bash function called active Docker that you use to select which Docker image you want to build or run or exist, build or run. So here's an image of a Docker that's been built up from a layer. So if you look at some of the underlying images, you'll find that they take an Ubuntu, some of them will take an Ubuntu Docker image, then they'll layer on a bunch of the ROS stuff, and then I layer on my layer, which includes some apps like Plot Juggler and other useful stuff that you'll like and find useful, and then you may layer on your layer that has your maybe some packages that you want to support P2OS, and all of that ends up being being in an image that is launched into a container. And when you launch a container, it ends up with a writable layer in it. So if you write to say /home/Bouchier, and you write some file, you're writing to the writable layer in the container. And in the way that we use containers, that will go away when you exit the container, unless you gave the flag that keeps it around. And if you keep it around, then that writable layer stays around, but it's not a part of the image. So does this drawing make sense in terms of the concept of images and containers and what you end up writing to?
Does for me
makes sense. Yeah.
The one question I have is how do conflicts get resolved or managed so that, like, you could perhaps unintentionally include something on a new layer that is a different version than something that's already existing in a previous layer? What happens then?
Yeah. So if a new layer overwrites a file, then it overwrites that file.
So latest wins?
Latest wins.
Got it. So you could technically have a raw, nobody would do this, but you could have an Ubuntu 2004 layer, and then you could have an Ubuntu 2204 layer on top of that, and it would somehow work as 2204. Is that one too messy?
That would be a really bad idea, because
all right, yeah. I hopefully would catch something like that, but it's just a general wonder.
Yeah. Layer 1 would be different between Ubuntu 2004 and 2204. So if you
exactly
2004 and then tried to layer on top, you might end up with remnants from 2004 that shouldn't be there, that would break 2204. So yeah, don't do that. So we configure the image to
Wait,
start.
and but yet you could still, like, your bare metal system could be 2204, and you could have an only 2004 layer as your base layer, and that would be fine
Yes,
because
yes,
it's
because
just
it's
a
running
kernel.
in the container, and
Yeah.
so it would have all the 2004 apps that you chose to configure in. For example, it's conceivable that they might have some app that's part of 2204 that's part of 2204 that's not in 2004. So inside of your 2004 container, you wouldn't have that app.
Yeah. But that would let you test in earlier releases, for example. Or,
Exactly.
Yeah.
Yeah. Yeah, it's a real powerful technique for going both forwards and backwards relative to the host OS. And it'll be helpful for you, Kareem, because you want to be able to still run Noetic. So you'd like to be able to run 2004 with Noetic or 2004 with Foxy on, for example, maybe a 2204 or 2404 host. But you'd also like to be able to run Humble on a 2204 environment. So you know it's real, like it's just great flexible stuff. So we configure the image to start a shell when a container is launched from the image. So that's different from your typical IT usage where you might configure it to start a database server or a web server or something. We start a shell, and the terminal which launches the container gets the shell connection, and other terminals connect to a running container and get their own shell using Docker exec. And so there's a concept here that is a little kind of like mind bending, perhaps. It's possible to launch multiple containers side by side. So we could launch a container and say run one ROS app in it. We could launch another container and run another ROS app in it. And I have the containers set up to use host networking, so they'd all look like they were on the same network, and the apps inside each of them would be just, they wouldn't know the difference. That's not how I prefer to run, but I don't know that there's really a strong reason not to. How I prefer to run, just to minimize the amount of stuff that is running at one time, and to make it simpler to shut down and restart. I recommend launching one container and then starting multiple shells within that. And the first shell is the one that you get when you launch the container. And then there's a script that invokes Docker exec that launches bash inside that container that you've got running. And so then you've got a bash window. You can start another app, and it looks to all the world just like they're in an OS. I hope I didn't confuse you there, because it's kind of a bit confusing. Did that raise any questions?
Only nefarious ones. If you have the different containers, would probably have different simulated MAC addresses and things like that. That if you're running shells within the same container,
No, not the way we run them, because we use host networking. So the host provides the network and the MAC address and everything, so they would look the same.
How do things like binding to certain ports get resolved in that case? Like, so there'll be the same IP addresses.
Yep, and
the same, like, if you bind to a port in one application, isn't that going to take it away from the other containers?
Well,
Or they will fail trying to bind to it, or will,
Right.
how does
Yes.
that happen? Yeah.
Yeah. So that's why you wouldn't do that. Right. That's like if
Don't
you
do
tried
that.
to run
Yeah.
that's like trying to run two conflicting apps that both try to
Mhm.
bind to the same port on a piece on a native OS, right? You know, one of them will fail.
Right. But so I guess I haven't really tried to peek deep under the hood in like how nodes, well, I guess they don't really bind TCP ports so much. Oh wait,
In
they
ROS
do.
one, they do.
Yeah.
And but the way it works in ROS one is the way TCP works is it uses ephemeral ports. So TCP a TCP server will accept an incoming connection on a well-known port, and then it picks a different port number which is called an ephemeral port, that's just, you know, for the use of that client, and tells the client, here's the port you should use in the future for talking to me. So multiple clients can connect, and they each end up with their own ephemeral port, and so that's how TCP works in a
Mhm.
normal OS. And it's the same thing inside of Docker, because Docker uses networking that's down in the kernel. So, you know, it's a shared kernel. And so I said
Yeah,
before
but
that,
for example, if you're running a web server and then you start up a different web server, they can't both
right,
just sit on port 80.
correct. I was speaking to it from the client's point of view. But yeah,
Right,
if you
on the
started up
return.
two web servers on a native OS, the second one's going to fail to bind to port 80. And the
You
same thing
can't,
would happen.
so you can't have you can't have two ROS1 containers sitting side by side in this mode if the ROS master needs to bind to a specific was it 11311 or whatever, or yeah.
Right. You couldn't run two ROS masters, just like you couldn't run two ROS masters on a native OS,
Mhm.
using the same ROS1 ROS master port.
But is there an option of using sort of like a NAT relationship or something like that to the host
Yes,
OS?
yes, you
Okay, so
can do
there
that.
are, just like any other VM, there's other options.
Exactly. Yes, it's
Okay.
possible to configure networking so that the container gets its own IP address, and consequently you could run two containers side by side with, and the Docker would give them. I don't know how that part of Docker networking works. I've never done that, but you can definitely do that.
Okay. Cool.
But it makes life a lot easier to do them, to use host networking, because you would run into the usual NAT issues when you do that. So if your PC is behind a NAT firewall, you have trouble SSHing into it from another host. So, you know, there are issues there, and the same thing would be true if you ran your container in its own IP space with behind the NAT firewall. Now you don't have to use NAT. You can just give it its own, cause it to have its own IP address, and it can be like another server with its own IP, and then it can use ports on that IP. You could have two ROS masters. You know, it really looks to the apps like it's so yeah, depending on how you configure it. I've recommend running it using host networking, because then from the laptop and the robot IP relationship, it stays nice and simple.
Right. Okay.
Great questions, guys. Okay, anything else come to mind in terms of launching a single container using Docker exec to get more shells, and actually, in what we'll normally do is in where we launch the either in a Docker exec or the Docker run where we ran Docker run to launch the container, we'd then start Terminator, and of course we can split Terminator into a bunch of sub windows which each have their own bash shell. So we've got multiple bash shells running inside the single container, and nothing cares. Everything works. It's just like another process, just like opening more bash shells in a regular OS. Let's see. From the shells, each terminal can run different apps in the virtual environment. So you could run a robot app in one, a ROS GUI in another, a ROS bag recorder session in another, and so on. Just like we were doing on Saturday in your OS native environment, in your on the metal OS environment, Kareem.
Yeah.
Okay, so I think at this point, I want to walk through what the hands-on. So that's it. That's the end of the. That's all the theory that I have to give. That's kind of Docker concepts. The next section is hands-on, and we could choose to do this. I'd like to walk through what it involves, because then I can send you away and you can do it on your own time. But we could choose to do it live here. And then the third section of this workshop is a deep dive into the scripts and how I've got these containers set up to run, and the things that you might want to modify.
Do you have an RPi handy where you could demo this?
I do. And actually, that's a really great idea. And you could follow along on your robot if you want, Kareem.
Mm-hmm.
And Brian, if you have a machine handy, either an Ubuntu machine or any kind of Linux machine, could be an RPi or a PC or whatever, you can do this too. The feedback that I got from the first time that I ran this workshop was it'd be helpful to send people on their way so they can try this stuff offline, get as far as they can get, and then come back and solve problems in a second session. But
I'm completely okay with that if that's what you prefer to do.
I'll take your input, but let's walk through and talk about what each of these sections of hands-on exercise do, and then we can decide to do that. And I could actually install Docker on my PyDog, which I've been wanting to do for a while, and you guys could install it on your OSs, and we can work through any problems that arise. It would be one thing we could do. So the first section, and where it says RPi here, Kareem, you should understand that I'm talking about RPi as a system that's resident on the robot. And I know you've got an x86 Ubuntu system on your robot, so just plug in the robot PC where you see RPi.
I've already got Docker installed.
Oh, you do?
So,
awesome.
Yeah.
Awesome. Okay, so you have done. You didn't need to do this. The only install difference is where you get the URL that you get Docker from. On Raspberry Pi, you get it from a Debian repo, and on x86 you get it from an Ubuntu repo.
Yeah.
And then you want to add this set of stuff here to .bash rc, and this is a whole bunch of support scripts that
This is your
like
customization, right?
this is my customization.
Yeah.
So there's the active Docker script. So something that I provide is Docker files that will build Docker images for ROS1 Noetic, ROS2 Humble, and each of them for x86 or RPi. So it's a total of 4 images.
But they're still based on the official open source robotics framework images,
Yes.
right? Yeah.
Yes. So Open Source Robotics publishes Docker Docker images for all of those things, for ROS1 and ROS2, the different releases. And so the Docker file that I created pulls in those Docker images that Open Source Robotics provided, and then
Quote
built
official sources, yeah.
from
Yeah.
official sources, and then adds layers on top of them to add all the customization, the useful tools. For example, it doesn't come with ifconfig. You always need ifconfig. You know, just as an example, there's a plot juggler. You want that. So yeah, that iLayer. This is where you select which Docker you want to run. Then we declare aliases for Docker build that is, gives the path and various options that you want. Alias dr for Docker run, runs a script, which we'll look at in depth in the final section. De for Docker exec gives you a shell in the running Docker container. DSL, Docker start the last active container. Okay, so you add that to your .bash rc, and then you change the setting of display in this script. Should be here somewhere. Yeah, change the display variable on the next line as needed for your system. And what I found, so here it says display equals :1. What I found in the first delivery of this workshop was people who had a monitor attached to their Raspberry Pi needed to use display :0, and then they got a mirror of what was on their physical display. People who didn't have a physical display need to use :1. So then you would source.bash rc, then you would run active Docker, and then call out whichever you're using, like ROS2 RPi, ROS1 RPi, ROS2 x86 Linux, or ROS1 x86 Linux, and that will give you either Humble or Noetic on the appropriate OS version. Next, you configure GitHub to allow your RPi to clone repos. So here's where we're setting up to clone the repo that I provided, which has these various Docker files in it that let you build these images. So you create a key and you put the key into your github.com configuration, and then you so here's graphics showing how you do that. And at the end of the day, you do a git clone, and here's the URI of rosdockers.git, my repo for the ROS Dockers, and you build the image, which can take 5 to 30 minutes, depending on your computer, to do the first time. So because it works it actually is quite smart about how it builds, how it works through a Docker file. So the Docker file has a sequence of commands like install ROS, ROS noetic, and then install plot juggler, and then make a symlink to where you'd store your bag files, and it only executes as much of the build of the Docker file as it needs to. So typically the first incantation where it's building from scratch, or if you remove the image and rebuild, that takes quite a while. But subsequent builds just take like maybe a minute or two at most. If you just, depending on where you're making changes in the Docker file, if you make them near the end, then it takes very little time. So then you the build. Okay, so you run docker build, docker underscore build, which is one of my aliases, and it builds the image, and then you launch the Docker by SSHing into your host, and you run Tiger VNC server on the and here it's running in. Let me just make sure I don't lie here. Oh no! What I'm having you do here is to launch a GUI or desktop, a VNC session to your robot computer, RPi or x86, and launch VNC, and then run DR inside the VNC container. And the benefit, the reason you do that is because part of testing this out involves launching GUIs, and so you don't have to. If you have a terminal on your robot, then you don't need to launch VNC. You can just do it directly from using the keyboard and monitor on your robot. But if you don't have that, then you would VNC in. But you got to have a GUI.
You want to VNC into the bare metal host so that you can control the container. And then when the container spins up, it will inherit the display, basically. Like
yes,
if you're running a full desktop
that's
image.
right. That's right. And you don't have to do that if you're going to run the display on your laptop. So, you got some choices here. So normally I don't run Ubuntu. Normally I don't run a VNC session. I typically don't have a monitor on my robot computers, and I don't run VNC, and I run Docker with a Docker on my laptop connected to the robot computer, and launch, for example, RQT to get GUIs that are on my laptop. See, so there's all kinds of ways that you can use this, and what we're doing here in this section of the hands-on is starting at the most basic level, just assuming you don't have a monitor and keyboard on your robot. If you do, then you don't need VNC, and then testing it by running TurtleSim node in one sub window, and that will throw up that blue TurtleSim window, and that's really why you need the GUI, be it provided by a VNC or provided by a physical monitor. And in the second window, run turtle teleop key and press the arrows and drive the turtle around, and and then you can start RQT, and that tells you that your ROS installation is good. You can get GUIs displayed. That's the point of this whole section on testing it. Does that make sense?
I think so. It brings the general area of like the interaction between the bare metal OS and the Docker containers, especially in robotics. One of the things that comes up quickly, like on an RPi, you have GPIO pins, right? And I think general reading seems to say that that's one of the areas where you might run into trouble where you're trying to access hardware, especially unusual hardware from within the container.
That's a great question, Kareem. And the typical way of handling that in a Docker environment is to mount /dev. So a Docker container can mount different different directories, file systems, or even single files from the host. And in that case, the host contains the file, and which, as you know, /dev has a whole bunch of special files, but they're still just files, and they apps
Everything's
running.
a file on Linux or Unix.
Yeah. So the app running in the container, assuming you mounted /dev, really can do all of the things to those special files that it could do to anything else, due to the fact that it's mounted. We also use mounting. This is a great. You launched a great question here, Kareem, because we also mount /ROS_WS/source. Right.
Yeah.
So that you can edit on your native environment. You can have VS Code. There's no need to run VS Code inside of the container. You can run that, and it can make changes that will persist to the file on the native OS. And when you go to run colcon build or ROS run whatever in the container, it goes off to ROS2_WS/install/whatever, and get so the way I've got this system set up is the source files live on the host, and I believe I've got it set up so that the install and install directories, I don't remember where they live. I'll look at them in a bit. I don't want to say something wrong here. But yeah, and also bag files.
And logs if you want them to persist. Yeah.
Right. I don't mount logs, but I do mount bag files. I typically find that I use bag files, and so use them from the host. So because what I'll typically do, got a huge monitor on my laptop, and so I'll just keep an SFTP session running into the robot, and when I've saved a bag file on the robot, then I just say in SFTP get this directory with the bag file in it, and then I can inspect it and run it on a big monitor on my laptop. Does that make sense?
Mm-hmm.
Okay. Let's see. So we addressed special files and mounting /dev, and that's how you would.
Sorry, this is a bit out of sequence, but
I actually don't have this. I think
popped into my head the question of, like, say your robot crashes or the battery dies and you didn't catch it. What's going to happen with the persistent situation next time you start up? You get your power restored and all that kind of stuff. Is your container like dead in this version, and sort of lost all of the context that you were in, or what?
The container, assuming it just like crashed, the container would be in some intermediate state. So whatever last wrote a file to it would hang on. Whatever last wrote a file, that file would be written in the container, and I think it would end up being spawned. So it would end up being an orphan. So that's one of the many situations where you'd end up with orphans lying around that you want to get rid of with Docker system prune.
Okay.
Because next time you run DR, it's going to create a new container. Now, if you knew that,
yeah, but you knew that you had some log files in there that you got to figure out why it crashed the system or something like that, and you want to recover that particular instance.
Yeah.
So that container.
So in that case, you could launch the remnants of that container, whatever the last state of that container would be lying around, and you can do Docker container list and find it, and then you could do Docker container run and run it, and whatever
wouldn't
file
run rebuild it.
You don't have to rebuild it. You can just rerun it. Just start it. Actually, I'm sorry.
Doesn't run build it and then start it if you have a Docker file?
No. Actually, you'd use Docker start. So you Docker start containers. You Docker run on images, and then that spawns the container.
Right.
So in the scenario you're talking about where the OS crashed, the container is still sitting around on disk, and you can Docker start it, and it'll have whatever files were written. Obviously, if some files were halfway through being written, they may be corrupt or something. Your mileage may vary.
Yeah. Okay.
Okay, so that's
like Jim joined.
Yeah, hi Jim. Let's see. Jim usually doesn't have a microphone. So Jim, I'm sharing out the window, and obviously you saw my post in the Discord channel, and you have access to the page that we're working through. So then now let me ask you, Kareem and Brian, there are two directions we can go here. We've walked through the hands-on, and you can either go off and do it, and we can meet again at whatever time is mutually convenient, or we can work through it together, and I'll do it on my PyDog, and you guys can do it on whatever computer you want to use, and we can solve any problems that we may run into. What would you prefer to do?
I'm happy to do it offline. I'm also happy to stay here as an audience if you want to sort of capture in this opportunity a quick demo of you doing it on PyDog, so to incorporate it. I'm thinking more about later viewers.
That's a worthwhile idea. What about you, Brian? What's your preference? Oops, Brian might have gone away.
Nope, I just had to get off mute. It took me a sec. Sorry. I have a similar view. I'm unprepared to play along on my own in real time with you guys because I don't have a Raspberry Pi plugged in and ready to go. But I would love to sit around and watch and learn what you guys do and try it on my own later.
Okay.
Is that fair?
All right. So that's a great idea, Kareem. I like the idea of having a walkthrough available for for later viewers. Let's see, Jim raised his hand. Did you have something? Do you want to type in a question?
He was just saying he was observing.
Okay. All right. Then let me get PyDog hooked up. And I got the real dog sitting behind me under my workbench.
I think these things always have a lot more value when you actually see, a lot, especially live if possible, but some sort of walkthrough of doing it as opposed to just the discussion.
Yeah.
So, yeah, I think that'll add value.
Okay, great. So we'll fire up PyDog. And I think, yeah, this should be all right. All right, so we'll get PyDog going. And
Which system are you seeing right there? Is that your laptop or must
this
be?
is my lap? This terminal is on my laptop.
Yeah.
So I'll just wait for PyDog to boot up.
There he is.
There he is.
Does PyDog have a name yet, or is PyDog the name?
PyDog is the name.
Okay.
And PyDog doesn't have ROS installed. PyDog is running, so lsb underscore release -a. So PyDog. Oh, that's
your laptop.
Yes. So he's running Bullseye release of Raspberry Pi OS. So there's no ROS installed, no Docker. Okay, let's get after this then. Install Docker. So let's here, and I know it's not installed, so I need to do the uninstall, so we can go straight to and installing using the apt repository is, I think, if I remember right, the way that I used it. So we'll just copy that, and there we go. So this is adding the Docker package repository to PyDogs. And then we get the latest version of Docker CE, Docker CE CLI, Docker containerd.io, Docker, all the Docker, the major the Docker packages. So there we go. Yes.
What kind of Raspberry Pi is on PyDog? Is it a 5, a 4?
4 with a I think I ordered 8 gigs, 4 or 8 gigs of RAM. And a 32 gig SD card. Just, not bad, but the SD card's probably less performant than an SSD would be.
And are you planning to put Humble on here, or?
Yeah. Yes. Okay. And okay, so now we verify that it got installed by running docker run hello world with sudo.
So by default, it would have been set to run on startup.
No,
Docker?
no. Oh, I'm sorry.
No, the Docker
Docker-
engine, not the.
The Docker engine. Yeah.
Yeah.
That's a good question. I don't actually know. So it couldn't. It looked for the hello world image. It couldn't find it. So then it goes off to the web or the cloud and pulls the latest library. So this is what Docker does. If it's asked to run, so since it's run, this is an image name. If it when it's asked to run it, if it doesn't find it locally, then it pulls the latest from the web.
Docker Hub. Yeah.
Downloads hello world : latest. So this colon syntax is you can have different versions of an image, and you can call out a particular version. I don't find that useful, but it's something you can do. Okay, so then we had to run sudo because we aren't part of the Docker group. So this tip is important. The Docker user group exists but contains no users, which is why you have to run sudo. So we continue to the Linux post install to allow non-privileged users to run the Docker commands and other optional configuration steps. So
this actually leads to another question that I have had, is that examples abound, and almost always when you're in the container, you seem to be running root.
Yes, that's a very common way to run it.
So you're relying on what for, like, intrusion prevention and that kind of stuff? You're relying on the host operating system for that? That doesn't make sense in terms of like web exposed stuff. So yeah, I was just wondering.
Well,
if there's a general concern about that or not, or like you have to be into the host machine before you can meaningfully gain access to all of that stuff. And I guess you're still only accessing the stuff inside the container.
Right.
But that can expose surface, right? Yeah.
It could. Yep. And absolutely, if you had some image that was internet facing, then it's being asked to defend against attacks, and you should. And so one of the safety aspects of Docker is they could corrupt the container, but they can't corrupt the host, except for any file system shared with the host. So
right. Yeah.
But if you're running like a web server, then probably that's not a concern. So it's a safer environment. It's not something we worry about because typically we're on a private network running our robots. Now on the instructions, I have a separate step to configure Docker to run for the non-root user, and this just goes to the same place that other link went to. So I just called it out because people wouldn't typically see that little tip there in the middle of that page. So, but we do want to, to finish off addressing your question about users.
Well, I didn't expect a full, because that's a giant rabbit hole, and probably an endless one. But yeah.
And I do something different in my container from those examples that you typically run. So the scripts that set up the container and run it are typically fairly rudimentary. They're just doing Docker run and some base image that they got from somewhere, and they end up as root, and they do something as kind of experimental. We need to be more sophisticated in what we're doing because we're sharing source with the host. So we want to have the same user ID as the host. Otherwise, we'll create files and we either won't be able to read them, or we'll write them and then they won't be able to be rewritten by the host because they're now owned by someone different. You can run into all kinds of problems. So I take special steps to make sure that, and you'll see them come into play, to make sure that the user in the Docker container is the same as the user ID of the on the host, so that file ownership isn't a problem. Let's see. So we want to create a Docker. Let's see. So we need to create the Docker group. So if we run groups here, there is no Docker group currently. So we will run that. Oh, there was.
Groups shows what you're a member of.
Oh, thank you. Yes, thank you. Okay, so then we do sudo, we add ourselves to that group, and then we log out and back in so that our group membership is reevaluated.
Couldn't you just SU to $user? I think switch user to yourself is the same as logging out and logging back in.
Yes, you could. You've brought up an important point that I didn't think of, a precondition. So let me just briefly go back to there's some configuration in the RPi and laptop configuration page here in the Docker workshops. And so a lot of people, when they install Raspberry Pi OS, take the default user of Pi.
Right.
You really don't want to do that. You really want your to be, when you're on your robot, you want to be the same user as you are when you're on your laptop, because then you can set up your SSH keys and you say SSH to PyDog and you pop in as, in my case, user Bouchier. So somewhere,
this brings up a whole other issue, because it's and this is, I've been looking for some sort of best practice around this. It seems weird to me to log in as yourself to your robot, except in some sort of supervisory capacity, like the processes that are running normally on your robot. I was wondering if there's like a standard around how you should name that. In particular, what happens when you're in a robot swarm, right? How do you handle user or robot identity in those kinds of situations? For development purposes, I'm completely comfortable with using it like a personal account that's the same on the various systems that you're using. But I was just wondering if there's like a standard in the ROS community around what you do. I've seen some people name their user account robot for the robot.
Yeah, you can do whatever you want. It just means that when you want to SSH to your robot, you have to SSH as
that user.
hi at robot name.
Right.
The robot names obviously have to be unique because they're in have their own unique IP address, and so you'll edit etsy/hosts and name your robot and say what it's tell the PC laptop what its IP is, and then you can get into it just seems to me that life gets a whole lot easier if you use the same user ID across your laptop and your robot, because then if you want to SSH and get your bag files up onto your laptop where you can analyze them more easily, you're not dealing with questions of ownership. Like user pi owns the file on the robot, and you hope it gets changed when you send it down there, or I don't know. Just life seems to me easier, but I don't know that there's
Sure.
any real.
All right, that was another tangent that we
practice.
didn't need to go down. Yeah.
I guess where I've worked in industry, they have had a standard user, so they didn't have your own personal user accounts on the robots.
Right.
So I guess industry practice would be to have a standard user on the robot, and then you have to deal with logging in as that user. It's not a big deal. But these instructions are set up so you need to be cognizant of what your username is going to be on the robot, and it really should be the same as what the username is in the Docker container, because since they're sharing files, particularly the ROS source files directory, you really need the whatever it is, it needs to be the same. So here I say my configuration user Bouchier is the main user account on both Linux laptop, and the RPi has the ability to commit to GitHub. That's the other reason to use your real ID, is committing to GitHub, because then the user ID can be Bouchier, and that has Bouchier's keys in it that can authorize to GitHub. So, life just gets simpler.
Yeah.
So you can do it either way. Let's see. I got here because of usernames. Yes. So that's what those are the concerns surrounding usernames.
Could you get around some of it if you had your user ID on the robot and the ROS container, and conceivably a different one on the laptop if it was isolated? I know better to have everything the same, easier at least.
Yeah, I'm sure you can find a way to make that work. I don't have Git in the container, I don't think, because I'm going from memory here. Actually, I shouldn't say that without checking it, but I typically do source file management on the base OS, and just use the container for running the ROS nodes. But you could do it differently, as you say. All right, so getting back to where we were, that was down a rabbit hole in terms of user mod. So I've added user Bouchier to the Docker group, and there I am. Okay, so now Now we verify that we can run the Hello World image without sudo. So that is the post installation instructions. We use docker run hello world. Okay, so we now run hello world as user Bouchier without having to run as root. Okay, and that's as much as we need to worry about in that section. Okay, so on the PC, it's real similar. So now we edit bash RC and add all this stuff. And we'll source it. Okay, so there's a note here. Change the setting of display in the Docker build as needed for your system. Maybe :0 if you have a locally connected monitor. I do not, so :1 if not. Identify the correct setting by launching a terminal in a VNC window and run echo $display. Okay, so we'll do that here shortly. Let's see, do I need to run Tiger VNC? Yes, so installing Tiger VNC was one of the setup steps that was in the previous tutorial. So I should gather those setup steps and pull them into this tutorial. Tiger VNC standalone server. Okay. Oh, so it was automatically installed. Okay, good. So let's launch that and test it. Okay, and it's launched it, and it gives me a command line to use to now a good thing to do here is to set up your VNC password so that this minus password option works, and you do that with VNC password.
Looks kind of a bummer, like that it says username and password right on the screen for everybody who's looking.
I don't think it does.
Okay.
VNC password. Minus user is what it looks like I need. Okay. And now Let me start up this Hex Tiger VNC viewer on my laptop and connect to PyDog:1, and we'll see how well that works. Look at that, beautiful. And so the instructions were telling us to echo $display and find out what it's set to, so that we can verify that we got the configuration script right. Come on, wake up. :1, good, just like it should be. Okay, and then we can shut down Tiger VNC server with Tiger VNC server minus kill :1. Hey, kill that. Okay, so we've done that now. We've set, we've verified that :1 is the correct thing. So now on the RPi, we're going to run active_docker ROS2 RPi. So this just points an environment variable at the correct directory that will contain the ROS2 humble Docker file. So now we configure GitHub to allow your RPi to clone repos. And you got to have a GitHub account, you SSH into the right RPi, you generate a key, and you run ls and you verify that it's there, and then use a browser to open github.com and add the key to GitHub, give it a name, you copy the contents, and you paste them into the web page. I'm going to bypass all of this stuff. You guys can follow the instructions, and I'm simply going to push down the credentials from my laptop, and that's how I usually do it. So SFTP, I don't know if you guys know about SFTP, but it's a super easy to use file transfer one-to-time CLI type command to PyDog and cd to .sh and run ls, and make sure. Oh, of course. I've already pushed it down because push my credentials down, because that's how I can SSH into PyDog without being asked for a password. So that means my credentials should already be set up for GitHub. Okay. Now what I normally do, where I've got, just so I don't get confused, where I've got a laptop window, a laptop terminal, and a PyDog terminal, is I keep them in separate windows, because otherwise I type the wrong stuff into the wrong windows. Okay, so now back to the instructions. We want to clone and build the ROS Dockers repo on the RPi. So this is going to clone my repo that has all 4 flavors of the Docker file in it, and then we'll build whatever flavor we want. Okay. And you see we now have a ROS Dockers directory. And it has ROS1 RPi and ROS2 RPi, ROS1 x86 Linux, ROS2 x86 Linux, and then a my RPi mods. And within each of them, and we'll look at ROS2 underscore RPi. Within each of them is a run it script that runs that starts the Docker file. There's the Docker file that tells how to build it. And if we look at the Docker file, I'm not going to go into this in depth here, but just to preview the sorts of things that go on in a Docker file. We start off with the ROS distro Humble, and we pull it from ARM64v8/ROS, which is the Docker repo owned by the Open Source Robotics Foundation. We pull Humble ROS base, and then we set a few environment variables, and then we start installing stuff. As we do apt-get update, upgrade, and then we start installing sudo and less and wget and inetutils ping and traceroute and nettools, which gives you ifconfig, and then terminator and python pip and turtlesim and desktop and plot juggler. So you can see how as Docker builds the Docker image with using this Docker file, it's installing stuff into a new layer on top of the OSRF's image. And then we configure some environment variables and groups, and that's about it. We set the entry point as ROS entry point with a command to run is bash. So that was a quick look at it, but does that raise any question in your guys' mind?
Not for me.
Okay.
Same.
Okay. So we cloned it. The active Docker command that we ran before, set to ROS2 RPi, sets the path to ROS Dockers /ROS2 RPi. So it's going to use that Docker file when we run the build command, which is here, and it can take 5 to 30 minutes depending on the computer. So we run docker_build. So now it's going to sit here a while. It's pulling down the base image from the OSRF repo. So this will be kind of boring to watch for a while. So if you guys want, I can go on a little bit into the next section, which is looking at the scripts that run all this stuff. Does that make sense for you?
Yep.
It makes sense. Unfortunately, I have to run away, but you guys continue on, and this is awesome. And I hope to catch the rest of it on cable or something.
Okay. Well, thanks for joining us, Brian, and hope it ends up being helpful. And when I've got a recording ready, I'll post it on DPIG Clips, and I'll link it to the video link in the workshop page, and send an email out to the list saying, you know, I did this I did this course, and here's the video if you want to watch it. All right. Have a good evening.
Bye, y'all.
See you. Um, okay. So while this is busy running, Kareem, move this over here so I see it. I can see when it finishes. So we'll go through this testing phase here once it all gets built, but that might be in another half hour. Do you have time, Kareem?
I can hang.
Or if you'd like to go off and get this far, then that would be all right too, and we can. You've seen
This might be a decent stopping point. Yeah.
Yeah.
I can go either way. At this point, you've at least shown the process of getting us to the point of building your customized containers and image for the Pi. So I think that'll get people pretty far.
Yeah, and the next thing that you should do, you should be able to build it now. And the next thing that you'll do will be testing the ROS2 Docker on your robot, and then assuming it tests out all right, then we don't really need to do the tests inspecting the scripts. That's more about diving into Docker so that you can modify it. So
Right.
yeah, let's call it a night here. I think this is a real good stopping point, and we'll I guess touch base by email if you have any problems. Let's get together again and we'll work through them.
Sounds great. Thanks so much, Paul. Really appreciate it.
Thanks for your time joining on this, Kareem.
To my benefit. All right.
All right. Okay.
Catch you later. Bye.
Talk to you later, Jim. Bye. This is the end of part 1 of the ROS Docker workshop. The part 2 will cover diving into the scripts and how that works, how the scripts work.